welcome back. Today's lecture, 1A, is going to be adding integers here in Math 094E, Introductory Algebra. And this is not algebra, this is part of the pre-algebra that goes along as an embedded topic. So I want to put a number line up here. In the middle I'll put 0, and to the right will be the way we count. 1, 2, 3. To the left will also be the way we count, going out to the left. But these will be considered negative because they're going to the left instead of to the right. It's actually easier to visualize it when it's vertical, because even though some people are dyslexic, 0 is the middle. If you go up, you've got positives like floors on a building, 1, 2, and 3. And then you have negatives that also go down, 1, 2, and 3. But you can see on that going up is positive and going down is negative. If you twist it counterclockwise, so if you take this and spin it that way, a quarter turn, you're looking at our number line, which is where we're going to have our x-axis, which is where the flat numbers go. To the right, positive, to the left, negative, right? I call that up the number line when we go to the positives, and down the number line when we go to the left. But it's not really up and down unless it's vertical like that. So what we have is, when we're dealing with addition, we have something called terms. This is an actual math name for the word. Terms are separated by plus signs. I'm going to put the plus sign in quotes like that, and I might even make that blue. Why? Because of something coming up a little bit later. Yours is probably a set of notes that's only going to be in one color, so you don't have to worry about that. But if you look at it and you see it in blue, that may help down the line when we're doing some addition, but not in this lesson. This lesson, not so much, okay? We need to have addition to proceed to reduce the terms, in our expression. It's not always called an equation, that's something in algebra, but we need to have addition, not subtraction. When we get to work on it, and we want it to work all the time, we're not going to try and memorize some rules like this is, oh, keep change, or whatever. We're not doing that. We're going to write it as addition, and we're going to deal with it as addition of terms that we're then going to combine based on the rules that we're going to learn here. So I'm going to ask you a couple questions. What's the opposite of 7? And what's the opposite of negative 2? If you're not sure, then you can stop the video right now, come with your guesses. I'm about to show you what's going on here. If we want to do the opposite of 7, which is actually, if I force you to say positive or negative, you'll say positive. The reverse of positive is to turn it into negative, but keep it as a 7. So the opposite of positive 7 is negative 7. The opposite of 7 is negative 7. When I just say 7, I'm speaking of a 7 that's positive, but I don't have to say positive. When I have the opposite of negative 2, I want to take it as still a 2, but I don't want it to be negative. I want to be the opposite of negative. That's why it becomes 2. So you might write it like this is the opposite, and that answer is 2. I use color here. If I want the opposite to be written with a green sign, color doesn't matter when we're looking at this negative 7 as our final answer of reduced opposite of 7. But if we look at our negative 2, which was already black, and we have the dash for the negative right there that you think it is a negative, it's actually the opposite of negative 2. And those will lead us to 2 of the names that we have for a dash. One is called opposite, one is called negative, and since we're doing adding integers on this lesson, we're not going to call it minus at all in this lesson. We're going to call it negative if it sits right in front of a digit. Digit is something that you would type on a cell phone, right? When someone says what are the digits of a phone number, those are the numbers only. You don't hit a button for the dash, you hit the digits only. So if we have a dash sitting in front of a digit, that would be called negative. If we have a dash sitting in front of another dash, that'll be called the opposite of. And that'll come up when we get into subtraction to help us get through a lot of the work we have to do there. So this is called the opposite of -2. That could have also been written all in black like that, but it's still the opposite of -2 is 2. Because if I say to someone who's way younger than a lot of us and say, what's the opposite of -2? They might say +2, they would be correct. They might just say 2, they would also be correct. When it's positive, we don't need to say the sign. In fact, we shouldn't most of the time. If we're insisting on seeing the sign, then we'll have to say that it's positive. So now, what we're going to do is we're going to have addition of terms. Addition is pretty cool because we can have multiple terms being added. Okay, you don't have to say, oh, I'm adding 2 terms, which one do you write first? When we talk about subtraction, that doesn't work that way. So you want addition because you can do it with more than 2 terms. But anyway, the result of addition is not called an answer, it's called a sum. If someone says, I want the sum total of all the things that I bought, I want the prices as a sum total, because you added them all up to get the total. And you can add more than 2 items together. You actually do them. You add 2 numbers together and you get something else, and you add another number, so you add it on one more at a time. But addition can keep on going, not with subtraction. So when we're going to deal with 2 numbers, we've got to decide to add 2 numbers. We have a couple decisions that we have to make every single time these decisions are going on. A, are they going to be together or against each other? Okay, are they going in the same or different directions? Are they going together with each other or against each other? Are they working together or are they fighting each other? When they go together, we're going to add the sizes. What's the size of 2? It's 2. What's the size of -2? It's 2. So I would normally stand on the desk. I'm not going to do that here, but my feet are on the ground and pointing in opposite directions, and my feet are size 9. And I'm going to say, how big is this one? And you'd say, that's a 9. How big is that one? That's a 9. True. The size of each shoe is a 9. One of them is a positive 9 because it's going up the number line. One of them is a -9. They have the same size. That size has a formal math name called the absolute value. We're going to deal with that as the size. We're going to add their sizes together if they work together, and we're going to subtract sizes. The size of a shoe never has a sign. So the size of a number never has a sign. It's called the absolute value. Formally, an absolute value is the value of a number without regard to sign. That's what people call it. So what I want to do is find that, and then B, we want to take the sign of the stronger term. And that will be the sign of our sum. When they work together, the stronger one will have the sign that they both have, and they'll go that far bigger in that direction. Right? They'll go bigger than either one in that direction because they'll add together and get a bigger number, bigger sign. A bigger size of what they're doing, but they're going in that direction. So, if you're going in that direction the whole time, the bigger number will have that sign. If they work against each other, the bigger number is stronger and wins the tug of war. So after you do the subtraction of their sizes, which you deal with them both like they're positives, see how far apart they are, you're actually finding what's called the difference between the two. And then the stronger one wins the tug of war, so the stronger one will get the value to have that sign when you're done taking the sum. That's it. So what I'm going to do is I'm going to put up here 4 almost identical sums, and we're going to find the sum of each one. If you get how to do it, you can stop the video and put all your answers down and then play the video through and see how you did. You can speed up the video and watch it fly through. But if you think you know what this is doing, once you pick up on 1 or 2 of them, you should try the others to see if you got the whole thing. But in each case, we're going to decide same or different sign, if they work together or against each other, and what's the sign of the stronger term. So here they are. 3 plus 5, 3 plus -5, -3 plus 5, and negative 3 plus negative 5. So I want to show you what happens on the number line in each case is if I go here and I go 3, 1, 2, 3, and then I go 5 more, 4, 5, 6, 7, 8, I wind up on 8. So that winds up getting me that. Now if I have 3 plus negative 5, start on my 0, I go over to 3, then I head back in the other direction to the left, 1, 2, 3, 4, 5, going as I go to 2, 1, 0, negative 1, negative 2. That's what the number line has me doing. Here you see one where they're working together, we got a big 8. The 5 was stronger, so it wound up positive like the 5. Here we wound up subtracting because they do not work together, they work against each other. So one goes to the right, one goes to the left, we wound up at 2 that's negative. Wound up with a 2 on the left of 0. And to do that, after we went through 0, we wound up in the negatives, and that's because the 5 was stronger. The negative of the 5 wins the battle for the 2 that we had. Now you can stop it if you think you got what's going on and try the next one. Start at 0. 3 to the left put me at negative 3. 1, 2, 3 to 0. 4, 5 up to 2. Positive 2. But the same old thing was, they don't work together, they work against each other. Subtract 5 minus 3 gets me the value of 2. The 5 is positive, stronger positive will get me a 2 that's positive. And finally, negative 3 plus 5. A lot of people get this one wrong because they think, I got this, I know this rule. Let's see. 1, 2, 3. So you're at 3. 1, 2, 3, 4, 5. Going 4, 5, 6, 7, 8. You wind up on 8. You're like, yes, I got it. Nope, it's negative 8. Okay, it is an 8 because they work together. 3 and 5 work together will always make me 8. If they work against each other, 3 and 5 will always make me a 2. Once I'm done figuring out I have some kind of 8, then I look and say 5 is stronger than 3, so that's what's going to drive my sign. Do they have the same sign? They do. But what happened is 5 is stronger, and the stronger sign always wins the tug of war of addition. So the 8 was found because they work together. 3 and 5 make 8 together. Look to the stronger 5, ignore what the 3 has on it. Negative answer. That's how we do these. So I'll address something that people get wrong with this a lot. I love doing this in the class, and I missed the opportunity to say it this time. But I'll say, come on, how many of you have ever heard, you can fill in the blank on this, and I won't hold it against you, but it's wrong to apply it here. 2 negatives make a positive. Yeah, somebody said positive back there. That's a lot of teachers teach it. That's incorrect, okay? What we have here is 2 numbers working together. They are 2 separate terms. When they work together, 3 and 5 will make 8. And the stronger sign of the 5 that's negative makes me get negative 8. So you don't say 2 negatives make a positive and get me an 8 that's positive there. So what we're doing, as importantly as anything else today, is if you think 2 negatives make a positive and you've known that for years, and you've been getting in trouble adding numbers, because 2 negatives don't make a positive. 2 terms add together, we see if they work together or against each other, let's get the value of the number. Which of the 2 terms, which are separated by a plus sign, is stronger? That will give me the sign of the value that we wind up with, the sign of our sum. So that's how the rule goes, that's how it's visible. They only made 8s and 2s, together makes an 8, against makes a 2, together makes, against makes a 2, and together makes an 8. If they work in the same direction, the numbers get added together. If they work against each other, the numbers get subtracted for their difference. You do it with positive numbers, and you subtract the easiest way to get the digit. And then, whatever the sign of the 5 was, because 5 is always grander, a bigger number than our 3, that'd be a positive result, negative result, negative result, based on what happened in step 1. So together against each other, get the value. What's the sign of the stronger of the 2 original numbers? Once they're set up as addition. So now I'm just going to string together a bunch of these and go through the process. You can slow down, stop, speed up, whatever you want to do with the video, but what you have is a series of me going through them without the number line in this case, showing how these numbers come up to what they are. You need to get each one of them right because I've made a purposeful mix of how these numbers work to make sure you don't fall into any old traps, tricks, or bad habits. Here they are. -3 plus 5, -8 plus 2, 7 plus -4, 2 plus -6, -3 plus -5, and -6 plus -4. You need to get every single one of these right and not say, oh, I got the first 4 right, but I have trouble with the other ones. I better memorize the trick. It's not the deal here, okay? So what I'm going to do is I'm going to proceed through each one at a gradual pace to the answer. You have control of the video, so you can stop it and try your own work and then watch me proceed through it. Or you can speed it through because you did it all in a hurry. You can stop the video, do all 6, and watch them roll out at a high speed. Whatever's going to work for you, but we've got to master these concepts. So each one, done in steps with me talking through. I normally in front of the class say, do they work together against each other? And the first time only 1 or 2 people say the right answer, nobody else says anything, and I say, did you have what they said? Next time you come in. And then more people come in and say together or against. And by the end, the entire class, by the time we get to the 6th one, is telling me whether they're together or against, and what's the sign of the stronger number, and at the end, the entire class has it by the time I get the 6th done. We're home, so you gotta build it yourself, but they're one at a time. Here we go. -3 plus 5. They have different signs, they work against each other. So I do 5 minus 3, I get 2. 2 is the size of my answer. And now I look at the 2 numbers that I have. The stronger one is the 5 and positive, so my answer will be positive. I say my answer is positive like the 5. Next one, -8 plus 2. So on this one, 8 and 2 have different signs. We subtract. 8 minus 2 gets me a 6. That's the digit of my answer. Now I look at 8 and 2, 8 is stronger, my 6 is negative like the 8. Onward. 7 plus -4. 7 and 4 have different signs, so they work against each other. 7 minus 4 gets me 3. 7 and 4, 7 is stronger and positive, so my 3 is positive like the 7. 2 plus -6. 2 and -6 have different signs, so I will subtract. They work against each other. 6 minus 2 will get me 4. And now I look at a 2 and a -6. Stronger one is 6, which is negative. My 4 is negative, just like the 6. -3 plus -5. They work together. They both go left on the number line. Working together, 5 plus 3. Always put the bigger number first, 5 and 3, on top. So that if you have to add, it's 5 plus 3, you'll get the 8. If there's a situation where you have to subtract, do 5 minus 3, do it the easy way. But these are together, so we get an 8. Stronger, 3 or 5. 5 is stronger, negative. My 8 is negative, just like the 5. -6 plus -4. So I have my 6 and I have my 4. They work together or against each other. By going in the same direction, each one goes left or down the number line. They work together. So that gets me a 10. So I can't even say the digit of my answer, but the digits of my answer make a 10. There's more than one written character for that number. What's stronger, 6 or 4? The stronger one is my 6. So I'm going to be negative. My 10 is negative, just like the 6. That's how we add positive and negative numbers. It doesn't matter which is first or second. What matters is whether they work together or against each other. They all had plus signs, right? In the middle of what was going on. Even if we had negative numbers here that were being added to what we had with plus signs, all right? We have rules of how to do addition. Now, what I want to show you is this thing called absolute value. I had mentioned that this thing called absolute value is the size of a number. That's exactly right. When we talk about the size of a number, like my shoes, I don't have a -9 on my right foot and a +9 on my left foot. They're both size 9. That's the absolute value. Absolute value of my shoe size is 9. So the absolute value, there we go, my badness. The absolute value of a number is the size of a number. I'm not going to write it. I'm going to say it fast. I don't want you writing it down. The absolute value of a number is the value of a number without regard to sign, which means give me the numbers, digits. If there's more than one digit, give me all the digits, which are keys that are present on your phone, your calculator for number digits, right? Single written numbers. So give me the size of the number without a sign in front of it. If it's positive, don't put a plus sign, just give me the digits. If it's negative, don't put the negative sign, that minus the dash that makes it look that way. Just give me the digits. The absolute value sign, wow. Are vertical segments taller than the digits. And they trap the number digits inside them. They're like parentheses, but they make the number not have a sign. So I'm going to go like this. This is not 121. This is not 1 minus 71. Okay. This is going to have inside the absolute value 3 plus 8. Inside the absolute value, this is not 19 minus 51, because those are taller. They're parentheses with a special thing that they do. Once the parentheses are done doing their work, they only want digits. So they want the size of what the parentheses contain. So if we have 6 minus 15 in the absolute value parentheses, let's see what they make. It's just a 2. What's the size of 2? Duh, it's 2. True. What's the size of negative 7? What are the digits when I do negative 7? Just 7. Also true. It doesn't always make the number positive. It makes sure it's not negative. If I want the absolute value of 0, don't make it into plus 0, it's 0. The digit is 0, you write it, you're done. 0 is neither positive nor negative. Guess what else? 0 is neither even nor odd. Okay, let's work on this guy. Inside the special parentheses that look like tall lines, we have 3 plus 8, which we know how to do. 3 plus 8 gets us 11. How big is 11? The number 11. What about this? We have our bars around whatever 9 minus 5 makes. Now I don't know 9 minus 5. I kind of think maybe I do know 9 plus negative 5. You might know 9 minus 5. If you do know it's 4, between the bars we have a 4. How big is 4? It's 4. Basically that's saying, what are the digits when I write a 4? What are the digits when I write an 11? What are the digits, or what is the digit when I write negative 7? What is the digit when I write 2? No negative signs allowed. Look at this one, pair of parentheses. It's got 6 minus 15. That's what we're working on in our next lesson. Some of you may know 6 minus 15 and some of you may not. But here's what's going to happen. In our next lesson, we'll look at specifically why 6 minus 15 is exactly the same as 6 plus negative 15. You see, we don't do subtraction. We need sums where some of the terms are positive, some are negative. So here we have 6 plus negative 15. Now that we can handle. 6 minus 15 we couldn't really handle. So on our number line, if we had 6 minus 15, it also says let's write the 15 on top and the 6 on the bottom, so we're ready to add or subtract. That's a positive 6. That's negative 15. They work against each other, so we're going to wind up doing subtraction. I'll give you a little more advice here. I don't have 15 fingers, and I'm not taking off my shoe to use my toes. What I want to do is 15 minus 6. If you know it's 9, that's awesome. You're good to have that already. But if you don't, 15 minus 6. What I want to do is get these to complete the tens. I got to get it so that each one gets to be up to 10. So what I'm going to do is I am going to give 5 more to this, so it ends with a 0, and give 5 more to this, so it ends in a 1. Now what I've got is 20 minus 11. Maybe that I could do, but I want them to end in zeros, right? So to complete the tens, You might do that, but you're still having too many fingers, not enough fingers to get that thing done. What I want to do is make this 6 get up to a 10. So to do that, I would need 4 more, and if I give that 4, I got to give that 4. Now we're dealing with 19 minus 10, and 9 minus 0 I know how to do. So if you have trouble with what your subtraction facts are when you have numbers where you need to borrow, right? What you can do is make the bottom number get an additional bit of numbers to bring it up to 10, put the same bit on the other one, and you're going to wind up subtracting a 0. Awesome. So now I got 9 minus 0, and I get my 9. That's a 9. So the digit in here is 9, and because 15 is stronger, what's inside those special parentheses is negative 9, and now I want to know how big is negative 9. Give me the digits of negative 9. That answer is 9. And that's what we have when we're dealing with absolute values. Absolute values are special parentheses. When they're done, they don't have a sign in front of the number anymore. So they say, complete my work, and when I'm done, give me only digits. And that's what absolute value does. But those tall vertical signs are absolute value signs, and they want to know what are the digits of this number when it's a single number. All parentheses are finished when they result in a single number. This is a special kind of parentheses right here. Then once we get the number for inside, we bring it out with no sign in front of it. And that's it for absolute value and adding integers. So that's the end of lecture 1A.